Okay, so we got the question was, what is the distance between 3, 7 and 15, 16, which are 2 points? So this is the short answer. So the short answer is we just use our distance formula, which I have on the board here. And you can see it says the distance equals the square root, and then they give you the points, x2, x1, y2, and y1. So the points, it's good to label them. It's a good practice to get in to label your points, right? So this one is x1, y1, and this is x2, whoops, y2. Let me see if I can draw that better. Okay, and y2. So all you got to do is then put your points into the distance formula and go ahead and calculate it. So if we do that, we'll get d equals the square root 15 minus 3 squared plus 16 minus 7 squared. And then you do the parentheses first, and you'll get 12 squared plus 9 squared. And then multiply those out, you get 144 plus 81. And add those together, you get 225. And the square root of 225 is 15. So that is the distance formula, and that's the answer to the question. So that's the short answer. The long answer is you can graph it. You can graph these points on your line and sort of look at the relationship you have here. So the first one is 3, 7, right? So let's see, x is 3, y is 7. And the next one is 15 and 16. Maybe I have to move this down a little bit. Whoops. Try this again. Yeah, if I could move it down. Okay. And then we get our dots back. Oh. Yeah, there they are. Okay. I'm going to do the dots again. Let's erase that. Okay, so yeah, the first one's 3, 7. Not very good. There. Okay, so the first one is 3, 7, which is here. And the next one is 15, 16. So you go over to 15 and up to 16. And they want to know the distance, right? That goes across there. Okay, and so you can see we're sort of dealing with the change in x and the change in y, right? So the change in x is going to be going across from here. So it would be this distance, right? That would be the change in x. And then we use the triangle as delta, means change in. And then the change in y is you're going from here to here. And we'll say that's the change in y, right? And so what you want to find is this line, right? So that's the distance. So this makes a right triangle, right? If you look down here, this is going to be a right triangle. So we can use the Pythagorean Theorem, and that says, let's see, what color should I do? I guess black. Says, let's see, do it here. So a squared plus b squared equals c squared, right? And so c is the hypotenuse, it's the diagonal line here. So if we put our what we're talking about into there, then a squared is the change in x squared, and then plus the change in y squared equals, and then we're doing the distance, so equals the distance squared. And we want to find the actual distance, not the distance squared, so we can rewrite that d equals the square root of the change in x squared plus the change in y squared. And the change in x is sort of, it's the distance, so it's the difference between these 2 points, or the x values. So that's going to be the first x value, or the second x value minus the first x value squared plus the second y value minus the first y value squared. So that's how you get the distance formula. So in our problem, we saw that the change in x is 12 units, and the change in y is 9 units. And then we used the distance formula, and we got this distance here is 15 units. So one thing you can notice, these are all whole numbers, and it's a right triangle. So the right triangle, there's some special right triangles that maybe if you're looking at this, you would notice, and you wouldn't have to use the distance formula. You would notice that if you have a right triangle, you can have a 3, 4, 5, and that's a right triangle, right? That's one of the special right triangles. And so this is just a multiple of that. This is, if you multiply everything by 3, then you'll get a 9, 12, 15 right triangle. So if you see the 9 and the 12, then you know the hypotenuse would be 15. So that's a sort of the long answer on how you would get this problem done. All right, thank you.